Welcome to Brain Vision.
To solve this question, we have to determine what is the acceleration of the skateboarder. In order to do that, we have to apply Newton's second law in the direction of movement. So he will move in this direction. Then I will choose that everything pointing there is positive and everything pointing to the other side is negative. Then, applying Newton's second law on this direction, we get the following. The net force in that direction is equal to the mass of the skateboarder times his acceleration in this direction. Then the net force has only one component, which is this component of the weight force. Let me call this weight X component. And then we also have this other component, which is not of our interest now, which would be the Y component of the weight force. Then, in the direction of movement, we have the weight force component X pointing to the positive direction, and this composes the net force. Then, it is equal to the mass times the acceleration of the skateboarder. But the X component of the weight force can be related to the weight force by using a decomposition of the weight vector. To do that, we have to take a look here in this triangle. So it's a rectangle triangle. And then we have to discover one of its intern angles. To do that, we note the following. This is 18 degrees. Then we can stretch the weight force down here so that this is 90 degrees. Then, if this is 18 degrees, this is 90 degrees, then this angle must be 90 minus 18, which is equal to 72 degrees. Then, the relation between the weight force and the X component can be given by the cosine of 72 degrees, because the cosine of 72 degrees is equal to the adjacent side, so the X component of the weight force divided by the hypotenuse, which is the weight force. Then the X component of the weight force is equal to the weight force times the cosine of 72 degrees. Then here we have the weight force times the cosine of 72 degrees being equals to the mass times the acceleration of the skateboarder. But remember that the weight force is given by the mass of the skateboarder times the acceleration of gravity. So m times g times the cosine of 72 degrees is equal to the mass times the acceleration of the skateboarder. Then we can simplify the masses to get an acceleration that is equal to g times the cosine of 72. Remember that g is approximately 9.8 meters per second squared. So here we have 9.8 times the cosine of 72 degrees. And this is his acceleration. But we have to determine what is the final velocity. So what is the velocity of the skateboarder at the end of that ramp? In order to do that, we now use Torricelli's equation, which says the following. The final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times the distance. Then v squared is equal to 2.6 squared plus 2 times the acceleration, which is 9.8 times the cosine of 72 degrees, times the displacement, which is 6 meters. Then the velocity is equal to the square root of 2.6 squared plus 2 times 9.8 times the cosine of 72 degrees times 6. This gives a final velocity of approximately 6.6 meters per second.